Hi guys, this is the last question I will like to teach you on the topic of Newton's laws of gravitation. In this topic, again we are taking a mass which is not a point mass. I have placed a mass m1 which is in the form of a semicircular ring, and I have taken another mass m2 and I have placed it on the center of the ring. Now our objective is to calculate the force of gravity between the ring and the point mass. So I want to calculate the force due to the ring on the mass, small mass m2. Okay, so look at this carefully. It is again a solution that will need integration. Again, it is very easy if you put your thoughts to it. Listen, the first thing we are doing is at an angle theta from the x-axis, at some angle theta. Okay, I have taken a small length dx. Okay, and of this small length dx, I have assumed its mass to be dm. I have already told you how to calculate this dm. I taught you that lambda, that is mass per unit length, we can calculate it for the entire ring or for the small portion of the ring, and it will come out to be same. So if it is same, then m1 upon length of the ring, which will be the length of the ring, will be pi r. Remember, for the complete circle it is 2 pi r, so for half the circle it will be pi r. So mass per unit length for the complete ring and mass per unit length for the small portion are equal. This gives me the value dm, the mass of the small portion, as m1 by pi into d theta. So I got the mass of the small portion. Now I write the force due to the small portion on our mass m2. So the small force between a small mass and a bigger mass will be F is equals to G m1 m2 by r square. The distance between them will be the radius of the circle. So if you got this, then I think you can easily understand that this force will be different for different portion of the ring, right? And of all these forces, I need not to add the y component of these forces. By symmetry, I can look and say that the net force due to the ring on the small mass will be along the x-axis, because all the component of such forces in y direction will be cancelled out. Remember, one quarter of the ring is above the x-axis, other quarter is below the x-axis. So the y components of the net force will be 0. So all I need to calculate is the x component and then integrate them. So the force due to a small mass g m1 m2 by r square, I am taking its x component. What will be the x component of this force? The x component of this force F will be F cos theta, because this angle is theta. So Fx, when I take the x component, dFx becomes g m1 m2 by r square into cos theta. Now the next thing is I will put dm as m1 by pi into d theta right here. I will make this substitution right here. After making substitution, I get this g m1 m2 by pi r square into cos theta d theta. Okay, you can try this on your own. It's very simple. And after this, all I need to do is integrate cos theta d theta, which is like the easiest job out there, because we know that the integration of cos theta is sin theta, and the limits of this theta will be from minus 90 degree to plus 90 degree. That's it.